Okay, so last thing we're going to look at this week is solving systems of equations. Again, we're still going to use substitution, but what we're going to look at is mixture problems. So kind of the idea of mixture problems is you might have, say, and I gave you this example earlier, a 10% red solution, and then maybe you got a 70% red solution. But 10 is too light. I don't want it to be that light. And 70 is too dark, so I don't want it to be that red. I want it to be in the middle. So maybe I want to get like something a little stronger than 10%. Okay, so maybe I want to get like a 25% solution. Right? And I know that I'm going to need like 10 gallons of it to like paint all the walls. Right? I'm going to need 10 gallons of paint. So you'd have something like, so you want a 25% solution, and you need 10 gallons of it. Those are always going to be the two pieces of information they give you. They have to tell you how much, or you have to find. So you got to figure out, all right, do I need like maybe 3 gallons of the 10% solution and 7 gallons of the other one? 3 and 7 would give me 10, but you got to make sure that it's the right color red that you want. You want it to be 25% red, right? And you can definitely get 25% because you got one that's a weaker red and you've got one that's a stronger. So if you mix the right amount of the two of them, you will get a 25% red. But that's the trick. You got to figure out how much of each one to mix, right? So that's kind of the goal of what we're doing today. Any question on that idea? So the basic thing is you have to set up two equations, and this is where the template is going to come in. So as you go through the template with Mr. Roy, just kind of keep in mind these are the two things you're looking for. One equation is going to have purely to do with just the amounts. Okay? Amounts of, usually it's a liquid. All right? That's what one equation is going to have to do with. Just the amounts of the liquid. The second equation is going to take into account the concentrations. That's like how strong it is. Is it a 10% solution, 20% solution, 50% solution? What is it? So one equation is going to have nothing to do with the percents at all. Okay? You won't even see them. Okay? The second equation will have to do with the percents. Now, one thing you have to keep in mind is anytime you use a percent, you have to change it to a decimal. So does anybody remember, like if you had 13%, how you write that as a decimal? Yep, 0.13. Right? If your decimal was originally here, you just move it 2 places to the left. What if you had like 26%? What would that be as a decimal? 0.26. Yep. And then what if you had like 5%? 0.5. Yep. Well, that 0.5 would actually be 50. 0.05. Because remember, if your decimal was here and you go 2 places to the left, you'd have to add a 0. All right? So that's one kind of simple thing that can trip people up. You've just got to remember to make sure you change percents to decimals. All right? Anytime you do use it in a problem. Any questions on that? All right. So what I'll do is I'll kind of start going through this with you. Once Mr. Roy comes up with the guided notes, did anyone bring them up that was with Mr. Roy, the guided notes? No? Okay. I'll just pause it and I'll let you copy down what we have so far.
Bam.
Never give one.
Can I give one? On the back. My stuff is in the back there. All right. So mixture word problems again today. All right, so they're gonna be, as far as the template goes, it's gonna be exactly the same template as we used yesterday. All right, it's the same exact thing. We're just gonna go through, guys, and we'll explain, because in terms of setting up the equations, it's a little, you gotta kind of do one more step than we did yesterday, right? When we're doing these, like the ones we did yesterday, where it said the age problem, where it said the sum of their ages is, remember we had to rearrange? It was like, whatever the person was, J plus C equals 52, and you had like minus one of the letters moved to the other side to get the variable by itself, so you could substitute. Well, for these ones, when we're doing the mixture word problems, it's the same thing. You have to rearrange, right, in that row 1 equation. So if it's a sum of their ages question, or if it's a mixture question like the ones we're going to do today, you have to rearrange the row 1 equation to be able to substitute it in. So we understand that. All right? So similar to yesterday, this is going to be in this box, in the subject box, that's just going to be the name of the solution. Usually when we talk about these solutions, we're dealing with like percent. So on your guided notes, you have an arrow coming out like that. You can put a little bracket if you want. So what's going in here, very similar to yesterday. Yesterday we had names of people. Today we're going to have a name of a solution. We're trying to get a 20% salt solution. 5%, I don't know, alkaline solution. 25% salt solution. So just like yesterday, the name of whatever we're dealing with in that problem is going to go here. So coming off that first arrow, the one furthest to the left on your sheet, is going to be, that arrow is going to be the name of the solution. All right? Here, row 1 equation is going to be setting up your first, these are going to be your single those are going to be your, just like yesterday. In the row 1 equation, we were dealing with the present. All right, today when we do mixtures, these two variables are just going to be single letters. A, B, X, Y, M, S, whatever, right? Just like yesterday, these will be your single variables, all right? Here, for my row 2 equation, it'll be for your row 2, for the variable, there's still going to be variables here like yesterday. Like we did yesterday, it was either the past or the future. So we used the same variable, but it was plus if it was in the future, it was minus if it was in the past. So we were always attaching something to that variable. We're going to do the same thing today. But today, instead of a plus or a minus, we're going to attach a number to that variable. What that number is going to be is, it all depends on what percentage of the solution it is. Is it a 20% solution? Is it a 50% solution? Is it a 35% solution? We'll just change, like Mr. Hager talked about, we're going to make that number, that percent a decimal, so 0.50, then whatever variable we used here will be attached to that number here. So if it was a 35% solution, 0.35x. If we used x as a single variable for the row 1 stuff. All right. Our row 1 equation. All right. it'll be whatever set up like this. Whatever single variables we used, X, Y, A, B, doesn't matter. Whatever we used here, equal to the amount we want to make. The amount's always going to be in gallons, quarts, ounces, whatever. All right? So here, our single variables, there's nothing attached. It's going to be equal to however much we're trying to make. However many gallons, ounces, whatever that particular problem says. All right? It's going to be set up just like that. That's why it says, where it says, we're going to have to write this setup. We're going to have to put it in that lineup box. Because we have to move stuff around to get the variable by itself. Like I just said, like yesterday, when we got the sum of their ages was 52. We had to rearrange. When we're doing these these mixture questions, word problems, we have to be able to rearrange to get a variable by itself. Just like the sum of ages we did yesterday. All right? And then for our row 2 equation, it's going to be it'll be percent.
Mr. Roy, do you want to set it up just like you did the other one?
What's
like
that?
Set up?
We can, yeah?
Yeah. Then it'll look the same. And all you're doing there is you're just adding two things again. So you got blank plus blank.
So here it's going to be, again, we're just going to take whatever we put in this first box of row 2, plus whatever we put for the second thing in row 2, equals, it's going to say to make, it'll make more sense when we go through the question, to make a 35% solution. So it'll be equal to 0.35 times however much we're trying to make. 50 gallons, 23 ounces, 6 liters. All right?
Can I just?
Sure.
Go, you keep talking, but do you mind if I just?
Yeah.
Okay.
So Mr. Hager he's just gonna tweak this a little bit. So just like yesterday, when we had Paul's age 5 years ago, right? It was P minus 5, and David's age 5 years ago. P minus 5, D minus 5, right? Whatever we're putting here and here are part of our equation. So like Mr. Hager, he's drawing some arrows. So whatever you put in this box is going to be there. Whatever you have in that box is going to be there. We're going to show we're adding the two things together. It's going to equal the other percent, whatever is in that problem, times how much we want to make. And like I said, as we go through it, it'll make a little bit more sense. Like Mr. Hager's showing you guys again. Whatever you put here, will go there. Whatever you put in that box, will go there. You just got to make sure for these type of problems that you rearrange. Or you have to rearrange to get a variable by itself. Good, Mr. Hager?
Yeah.
Right. So just like yesterday, we took the person how we represented that person there, we put it here. Whoever represented that person there, we put it there. It's the same exact idea. The only thing that's really new today is you have to know that your second equation, you have to do whatever the other percent is times the amount you want to make. That's like one more step. All right? Good, Mr. Hager? Scroll back up.
Yep.
All right. So how many liters of a 20% acid solution must be mixed with a 60% solution? All right. So what's our first percent going to be? What's our first subject going to be? What's one of the solutions, Matt? 20% solution. That's one of the things, a 20% acid solution. What's the other one we want to try to find? 60? 60% acid solution. If you just put like 20% acid, 60% acid, that's okay too. If you just put 20%, 60%, chances are it's going to be okay too. All right. How do we want to represent that 20% acid solution? I don't care what we use. Does anyone have a letter they prefer?
A for acid?
We can use A for 20. We use A for that. How about for the 60%?
S.
Use S, we could use B, doesn't matter. Alright, so here's my two things, my A and my B. Alright? Let's set up our row 1 equation.
Thank you.
Scroll down. I'm gonna do it just down here. Actually, I'll do it in here. Again, I have to put it in the lineup box. All right. So what am I gonna do with those two letters?
You're gonna put them in.
What operation is gonna be between the two of them? Addition. So what am I gonna write in the jelly?
A.
Yeah.
Plus B.
Okay. It's got to equal something, right? It's got to equal the total amount we want. Gallons, quarts, whatever it's. How much are we trying to make?
40.
40. Equals 40. Now, is that all set to substitute?
No, don't you put switch around?
Yes, what do I do?
You can put a variable on like one side or something like that.
As I want to get a variable by itself.
Yes.
So which one can I get by? I can get either one by itself. It doesn't matter.
Yeah.
How do I do that?
Subtract.
Subtract what letter?
A.
A or B. I'm going to subtract B.
Okay.
Is that okay?
Yeah.
So I'm going to minus B from both sides. My new equation is going to be, not my new equation, but my equation that's rearranged will be what in the jelly? A equals?
A equals B.
No, let's do 40
Okay.
minus B. That's how I rearrange it. A equals 40 minus B. So my first equation, all set. Let's scroll back up. What's my variable gonna be for my row 2 equation? Someone tell me by raising their hand. What's the variable gonna be for my row 2 equation? Now I'm gonna attach that percent change to a decimal to that variable. I'm going to attach the percent change to a decimal to the same variable from row 1. Remember, I'm not doing age now. There's no subtraction or addition in this part. I'm just all I want to do is take the same variable, which is A. What's the percentage? 20. And I want to change that number to a decimal. So where's the decimal point go? Donovan? Before the 20 or after the 20? Before. So 0.20A.
Yes.
0.20A. Again, I'm taking this, it's the same variable, just attach the percentage to it and change it to a decimal. So if this is 0.20A, what's going to go there in the box below it? G?
0.60B.
0.60B. Very good. There we go. Now, here's my setup. All right? So now I got to set up my row 2 equation. Can someone tell me up until the equal sign? We don't have to do the end part, the percent times the amount. Let's just set it up before the equal sign. What plus what?
Oh, 0.2A
0.20A
plus 0.6B.
plus 0.6 plus 0.60B equals how much of a percentage of a final solution am I trying to get? Someone tell me by raising their hand. How much of a final solution am I trying to get? Ellie?
35.
35. I want to make that a decimal.
So 0.35.
0.35. Very good. 0.35 times what? How much am I trying to make?
40 liters.
40 liters. If you want, do you want them to wait until they plug everything in to simplify this, or can they simplify it beforehand?
Either way.
All right, I'm going to simplify this now. I'm going to do the 35.35 times 40 now. So 0.20a plus 0.60b equals, I got 0.35 times 40, 14. All right, so now I'm at the same point as yesterday. All right, I have my row 1 equation. So what letter am I going to substitute for? What letter is by itself in that row 1 equation?
A.
A is by itself, right? So what does that mean? Wherever A is, what am I going to write? I'm going to substitute, right? So what information am I substituting in for A?
14.
Nope. Here's A, here's A. This is what A is going to become.
0.20.
So what am I writing in for A?
40 minus B.
Good, Angelica. So it's going to be 0.20 A, which Angelica just said is going to be 40 minus B, plus 0.60 B equals 14. If you didn't do this multiplication before you plug stuff in, that's okay too. I figure it's one less piece of arithmetic that you have to do. All right? So again, just like yesterday, I'm taking the variable that's by itself, that's isolated. I'm plugging in this information for this variable in the other equation. That's why A is highlighted here. Because I'm plugging in 4, that's how I got this 40 minus B, because I'm plugging it in for that. All right? Now I'm set to solve. So to solve, what's the first? I'm here now. What's the first step I have to do? Magellan? Multiply, okay.
40.
All right, so I'm going to do 0.20, right?
Yeah.
Times 40? 8.
So 8B.
No, just 8, right? I'm doing 0.20 times 40.
But what about B?
Now I'm going to do 0.20 times negative B. If I do 0.20 times negative B, what do I get?
0.20 negative 1.
Negative 0.20 B. Good, Magellan.
Yeah.
Everything else I'm going to bring down. Savannah, what can I do now? Yeah, I got negative 20B, negative 0.20B, and a positive 0.60B. I'm going to combine like terms. I did nothing with this 8 because there's no other number, because the two other things we have a B attached. I can combine them because they're the same. I can't do anything with that 8 because the 14's on the other side. I can't combine them. So I'm going to get 8 plus 0.40B equals 14. 2 more steps. Like Angelica just said. Subtract 8. Subtract 8. 0.40B equals 14 minus 8. Anybody know? 6. Last step will be what?
Division.
Divide by what number?
40.
0.40. B equals, we're not sure, we'll use a calculator. 6 divided by 0.40, 15. So B, which is what, B was what, my 60% solution?
Yeah.
So B, my 60% solution was 15. How am I gonna get my, what is it, 20%? How am I gonna get my 20% solution? Ellie?
Would you do, let's see, like 20 times 15?
No. Jake?
Plug it in right equation one.
Yes, tell me what to write, Jake.
So we have to.
Equation 1 is what? Tell me.
Equation 1 was a.
Like it?
Huh?
Okay, what else? A what?
Equals.
Yep.
40.
Yeah. Minus B. We know what B is now, right? So instead of B, what am I going to write?
So you would write 15.
15. A equals 40 minus 15. A equals, what would I get? Anybody know? 25. A equals 25. All right?
You get nice numbers on that one.
Yeah, I think most of the time we will. So 20 liter we just figured out was 25. We need 25 liters, right? Yes?
Yes.
And then for 60 was 14? Yes?
Yes.
Yeah.
Is it 15? Yeah, right. I'm sorry. 15. And then equation 1, A equals, you want to write in what you rearranged, 40 minus B. And your equation 2, well, we'd accept either one, guys. We'd accept before you simplify the 0.35 times 40 or after you simplify. I'm going to do the bottom one because it's less writing. So 0.20A plus 0.60B equals 14.
So it does kind of seem like it's a lot of steps, but the good thing about these problems is the steps never change. Like that's how it is every single time. Just a different number for the percent. But that's how it is every single time.
Because the age ones can be a little bit different because here you could be subtracting if it says years ago, or if it said in a certain number of years you have to add. This could also change your row 1 equation. It might say Jim is 3 times Paul's age. That's easy, right? It'll already be set up so you can just plug it in. Like I've said a couple times, if it's a sum of their ages, it'll be Paul plus Joe, P plus J equals 28. That's when you have to rearrange. So sometimes for the age ones, you may not have to rearrange. For the mixture ones, you always have to rearrange because it's the two mixtures added together equal the amount you want. Liters, gallons, quarts, doesn't matter.
Can you just go down real quick?
Sure. And again, notes, you'll be able to use your notes tomorrow. The homework you get tonight, which will be a review of both age problems and mixture problems you do today, you'll be able to use that. Notes from yesterday, basically, whatever in your notebook, you'll be able to, whatever in your binder or notes, you'll be able to use tomorrow on the test. All right?
Mr. Ryan,
Yo.
would you be able to stay after school today? Or
I can't stand today. I don't think there's any after school today. Do we have a meeting today?
I have a
Ellie, I'll get back to you.
department meeting.
Yeah, guys, I will, if I can stay after today, because I mean, I can stay, but I still don't have a meeting. I'm not sure. If I don't, just take a look at Google Classroom before the end of the day, and I'll post it. All right? So we got this. I'm sure there's late buses because there's sports.
Yeah.
Good with that. Actually, I'll find out before the end of class whether I can stay or not. All right?
Alright.
Good? All right. Let's try this one. So you already have the example written. Somebody tell me, how about Nicole? Tell me the first solution. 20%, yeah, 20% alcohol. All right, that's one. I got that. How about Joe? What's my other solution? 30% alcohol.
And if you look at like a bottle of rubbing alcohol, it usually does have the percent on it, like 71% rubbing alcohol, and the rest is water. If you look at any rubbing alcohol, it says it right on it, 8%.
Unless it's here.
Natasha, what should I do now? Say again? Yeah, what do you want to use? There's no wrong answer. A and B again, that's fine, we can do that. A and B. Now, when I go to set up my row 1 equation, should I just go ahead and write it right in the box that has the parentheses? Should I have people say, yes, I should, just go ahead and write it in the box with parentheses? Everybody says no. Alright, why are we saying no for? What are we going to have to do in these type of problems? We have to rearrange, right? Matt, can you tell me, I'm going to put it in the lineup box, right? So I have to rearrange it. What am I going to write in that line? What's my equation going to be before I rearrange it to get a variable by itself?
A plus B
Yeah?
equals 24.
Careful. That's the percentage. I want to know the total amount. Gallons, quarts, ounces.
25.
A plus B equals 25?
So if you use A and B, every single time you could just put A plus B equals. And then you have to look at the number.
Again, whatever gallons, quarts, whatever the unit of measure is in that problem, that's what it's going to equal. Donovan?
Do you use all 4 of the numbers in the equation?
You will end up using all 4. You'll use that other percentage. How much, like you're trying to combine the 2 percentages together to get another percentage. That's what you use. You use that in row 2. Because it equals the percentage you want to get times how much you want to make.
Okay.
The percent, the liters, quarts, ounces, gallons, whatever you're trying to make.
Yeah.
What do I have to do with this, Bethany, to get it so one of the variables is by itself and I can plug it in? Just like we did in the last one. Let's subtract the same letter.
Oh, you just subtract 25.
No, I want to leave the 25 where it is. I want to subtract the letter.
A.
We could subtract A. Alright, so we can do it the other way around this time if you want, it doesn't matter. So on this side, what am I left with? If I'm subtracting A, what's left here before the equal sign?
B.
B equals
25.
25. And what did I do to get A to the other side? So minus what letter? A. Perfect. You can do it either way. You can move the B, you can move the A. Let's do B this time so you can see it's going to work out.
Just gonna change which one you find first.
Yeah.
You still gotta find both.
Well, scroll back up. Someone tell me, row 2, how am I going to express 20% alcohol? Donovan?
0.2.
0.20, let's go 0.20. 0.20.
Then 0.30.
Okay, anything else I need with those, Donovan?
A and B.
A and B. Remember, I'm taking the variable that's here and attaching it. A, using the same, like we said when we went over all the steps. We're using the same, we want to use the same exact variable, and we want to attach to that variable the percentage changed to a decimal. So it was 20%, we changed it to 0.20. It was 30%, we changed it to 0.30. That's all we're doing. So in that row 2, whether it's an age problem, whether it's a mixture problem, we're always gonna do something with the variable. Add or subtract for age problems, attach the percent as a decimal for mixture problems. Right, we're always doing something with the variable in row 2. Alright? Cool. Ellie?
So would you do 0.20A plus 0.30?
0.20A plus 0.30B. I like that so far.
Oh.
Equals what?
25? 24?
We can use 25. That's how much we're trying to make, right?
Yes.
We're trying to make 25 gallons. Anything else, Ellie?
Times 24?
Just be careful with the 24.
I like it. Close, so close.
20%?
Look at you.
4%?
What do we want when we're doing these type of problems? What do we want to do to percent every time? Change it to a,
Decimal.
so it should be what?
0.24.
0.24. That's where some people get tripped up on these. You've got to make sure for that second equation, you've got to make sure you have 2 things that you have to multiply. The mixture you want to make, the percentage of the mixture, in this case we want to make a 24% solution, and then how much we want to make. In this case we want to make 25 gallons. Right. I want to simplify this first. So 0.20A plus 0.30B equals, calculator, let's clear it. Oops, maybe not. There we go. What is it? 25 times 0.246. Okay, so we got that. It said it'll say these steps, these little reminders will be on the template tomorrow that you have on the test.
We don't have any reference to it on it.
But this will be on the test. And you'll be able to use your notes. Substitute what's in the parentheses from the row 1 equation for the variable it represents in the row 2. So Mr. Hager is going to help us out. He's going to put some, he's going to highlight. So there and there. So anyone want to take a crack at what my new equation, what my equation is going to be when I plug in the row 1 equation to the row 2 equation? Donovan?
Point 20A.
Point 20A, yeah.
Plus point 30, parentheses, 25 minus A.
Yeah.
Equals 6.
Perfect. Blue for blue. Wherever I see this letter, I'm putting this information in the other equation. Houston?
Actually,
You okay?
yeah.
What do I want to do now?
Distribute.
Like Donovan just said, distribute, right? So 0.20A plus 0.30 times 25. Agree, Mr. Hager?
Yes.
Okay. 0.5. Then I'm going to do 0.30 times A. When I do that, what do I get?
0.38.
0.38. Let's put them together. Equals 6. Anybody know what I can do now? Just like in the last one we did, these things happen to be side by side, but here they're not. What do you want to subtract? Jelly? We could do that now. We could. You know, it's not going to change anything. We could do that. But it's something we can do. Mr. Hager's kind of helping us out. We can do something first. Ellie?
Subtract 0.28 from 0.38.
So 0.20A minus 0.30A.
Yes.
It's going to end up giving us a negative 0.10A plus 7.5 equals 6. Now, Jelly, we can do what you said. What did you say before? Subtract 7.5. Minus 7.5 minus 7.5. So negative 0.10A equals, if you're not sure if you're afraid of the decimal, just pop it on your calculator. Clear 6 minus 7.5, negative 1.5.
So at this step, you might be like, wait a minute, we shouldn't get a negative amount of solution, but watch what's going to happen.
Oh.
You're not going to get negative solution.
Jake, do you know what to do? Divide by what number, buddy? Negative.
Point negative 10.
Negative point. So we're going to do, we know, like Mr. Hager said, we can't have a negative amount of solution, but I'm not. Why? Because we have negative divided by a negative will be a positive. So we got, clear, 1.5 divided by 0.10, 15. So A equals 15. Now tomorrow on the test, if you get to the point you're like, I'm not sure. Again, you've got a little hint here. Substitute the solution into the row 1 equation. So A equals 15. Substitute the solution into the row 1 equation. So what am I going to write? Ellie?
B equals 25 minus 15.
B equals 25 minus 15. B equals, anybody know?
10.
10. So now I'm going to do is go up and fill in my information. I got 15 and 10. 15 and 10.
The
My equation 1 is right here. B equals 25 minus A. My equation 2 is right here. 0.20 A plus 0.30 B equals 6. Again, so you guys, even if you make a mistake with your arithmetic, you'll still get credit if you set up the equations correctly. All right?
So there's 6 problems on the test, but each problem has 4 things to do. Like equation 1, equation 2, and then the 2 answers. So you can get up, there's like 24 answers on the test.
So guys, we still got to leave that out, because there should be a spot on there for one more, right?
Yeah.
There's a spot on there for one more. I want you guys to practice a little bit. That way, in the last few, and I'll make sure you get the homework before we leave. That way, if you have any questions, we have about 15 minutes, like 14 minutes left of class.
13 minutes now.
15 minutes, sorry. All right, we can take a look at that stuff. Tomorrow, homework tonight, age and mixture. So the stuff we did today and the stuff we did yesterday. I think there's like 5 problems total.
Alright.
So a combination of both. Like Mr. Hager and I have said a couple times in the last couple days, test tomorrow. And remember, you can use anything in your notebook. So make sure you have your notes and stuff with you from this week. All right? Reason why is I won't be in class on Thursday because I'm doing the MCAS review with the sophomores. So we wanted to move it up a day. That's why we're letting you guys use your notes, because we had to move it up a day.
I wish your sophomores luck.
Thursday, like I said, I won't be here. We're gonna have you guys do a little, do an MCAS open response that deals with, doing like a word problem that deals with like a system of 2 equations. And then we have no class on Friday, periods of 3, 4, 7, 9. I had nothing to do with the schedule. They told me what it was. I want to remind you guys. And remember, we still have 1 week left of, we still have 1 more academic week after this, for this quarter.